Welcome to CLI 5353, the future of gaming on Windows Mobile. If you're looking for another session, you still probably have a few minutes to run to one of the adjacent meeting rooms. My name is John Marcantonio. I'm a program manager from the Windows CE Multimedia and Graphics team. And today, I think this is one of the more fun talks I get to give, looking at the future of the technologies, looking ahead at technologies for mobile gaming development we'll be seeing in future releases of Windows Mobile. I know a lot of the talks you've been to today or the past few days have been focused on a lot of the very now technologies, things you can start coding on, things you can get your hands on. This talk I find to be fun in that we get to really look ahead and see where Microsoft is going for mobile gaming development and what opportunities will be available to the development community as we look ahead. Now, there's a lot of material to go through. I, of course, welcome questions. I'd appreciate it if we could cover them either at the end of the talk or, time permitting, you can find me afterwards to follow up with me as well. So, the future of mobile gaming, what does that mean? It's a rather broad set of terms, broad description. When Microsoft looks at the future of mobile gaming development, particularly on the Windows Mobile platform, we think of DirectX. For those of you unfamiliar with DirectX, this is a gaming and graphics development technology that the desktops had for a number of years, designed specifically to create content, originally for the desktop, then for the desktop and also the Xbox. And when we look ahead at mobile gaming development, we'd like to expand that ecosystem to include Windows Mobile as well. So during the talk today, I'd like to look through a number of DX technologies that we're evaluating for future Windows Mobile releases. More importantly, what does that offer you? What does that offer the development community as far as a tool? Certainly there's benefit to Microsoft saying, well, we can expand the ecosystem, we could have more Microsoft-like technologies at your disposal. But unless there's a significant advantage, even I would ask, well, why do that? And I'd like to jump into that. Then, more particularly, some of the technologies we're actively working on now and developing to present to you in future releases of Windows Mobile, and also technologies from the DX realm we're considering and evaluating for even further releases for more long-term projects. Also, as with most developers, the one question even I would ask was, when can I get my hands on the bits? When can I start writing content? Well, there'll be some timelines, hopefully, that we can help guide you to understand when you can start to evaluate, when you can start development, when you can start to gather your knowledge base to start looking ahead at these future technologies and capitalize on them. And again, questions or comments at the end. Now, this is a slide I'm sure everyone's seen once or twice through the various talks here. Thought I'd include it myself as well, but from somewhat of a different perspective. From mobile gaming development, excuse me, as we look at the various releases from 2000, 2002, even 2003 second edition from today, not only has the platform become more advanced, the software has become more advanced, the architectures we're looking at these platforms being based on become more advanced. Sure, there's still an ARM-based core, but we're seeing more advanced DSPs, higher resolution displays, more powerful graphics hardware on devices that enable more powerful content creation. And in looking at the future of Windows Mobile platforms and devices, the more powerful these devices become, the higher the expectations become for greater content. If you're making games, selling Pong on a multi-100 megahertz device with a full TNL and rasterization pipeline may not be the most compelling content. The bar is going to be raised. And from a development point of view, we want to ensure, Microsoft wants to ensure, that we also provide tools and access to the development community to capitalize on the operating system, to capitalize on the platform, and really make the best content available. This is another slide I'm sure that's crept up once or twice. But this is really looking ahead at the vast variety of technologies we're looking at in the development community. And the one thing in particular that we'll be focusing on today, or one of the things we'll be focusing on, this little D3DM thing sitting in the corner. For those of you who have heard some of the news, heard some of the press, this refers to Microsoft's Direct3D Mobile initiative, which we'll be drilling in on in detail during today's talk. This is one of the most exciting graphics technologies we see being brought to the mobile space. As the name implies, Direct3D Mobile is a Direct3D-like API designed specifically for Windows Mobile platforms, with the predominant applications being mobile gaming development. So, gone on DX, gone on some of what the desktop has, some of what Windows Mobile has. Why is this important? Why even look at it at all or consider it? We consider the broad spectrum of the Windows product family, everything from spot watches to the left to enterprise applications to the right. There's a large sweet spot in here, particularly now the Xbox, Windows XP Home, XP Professional, that really target gaming applications, consumer applications, with DX technologies. Now, included in this that crosses both the consumer and the enterprise space is Windows Mobile, is Pocket PC and smartphone. And today, DX technologies don't exist in this. So by including DX technologies into Windows Mobile development, or in the developer's hands, we can create a gaming development ecosystem that crosses a wide spectrum of these devices. So Xbox and Pocket PC, smartphone, and Windows XP will all have a common development base, a common knowledge base, a common way to move forward. Well, that's all fine and dandy. But someone asked, well, John, what's the real advantage to that? Why am I doing this at all? There are two fundamental reasons we see looking ahead at DirectX. One, DirectX isn't a new technology. We're not reinventing a new API just for the sake of people to learn it. DirectX has been around for a number of years. Right now, there's version 9 on the desktop that's being used of its technology. People are familiar with the APIs. People understand which code paths work better than others, how certain API constructs work, what the structure of the API is. Now, I'm not going to stand up here and say that writing a piece of content for the Xbox is going to be the same as writing for my smartphone. Obviously, there are drastic differences. But if we can consolidate the API, consolidate a large set of the knowledge, there's also a large amount of similarity that can be leveraged, saving development costs and getting content to market. The other key component in DX technology is content availability, which is perhaps something we haven't really dug into or thought of as much as we should be. As we see Windows mobile devices advancing, higher resolution screens, more powerful processors, we follow the trends, we see that these hardware platforms are starting to encroach upon what the desktop technology was 6 years ago, 5 years ago. They're becoming far more similar. As a result, content written for, let's say, a P2 or a high-level P1 on the desktop can start to be applied to the Windows mobile space. A lot of this content was written for DirectX. Now, this content, if you go down to CompUSA today, if I look for a DX6 level PC game, even in the bargain bin, I'm probably not going to be compelled to buy it. But if I can find that same type of game, that same type of multi-user experience on my Pocket PC or my smartphone, that becomes very enticing content. So right now, we look out and see large stockpiles of content, IP, artwork, engines that have been written to DX that are sitting idle because no one's using it. So we ask if we can provide a mechanism by which that can easily be brought over or leveraged in the mobile space. Is there value to that? Microsoft certainly thinks there is and wants to extend that value to you, for your archives, for your partners, for how you work and create content. So there's a lot of content out there, but if you're writing code, how does this help you? Sure, you can port. People port code all the time from one application or one engine to the other. When we look at DX, DX is a known technology. It's a familiar technology. People who have used it on the desktop, if they move over to a DX-like API in the mobile space, there's very quick ramp-up time. People have been using internally at Microsoft some of the DX technologies we're bringing to Windows Mobile and importing over some large-scale samples and applications. It's on the order of, excuse me, it's on the order of hours to bring over this content to have it compile in our space as opposed to the desktop. The best indications we've seen from speaking with developers, from getting feedback from the community, is on a large segment of the DX technologies we're evaluating and developing now. Developer can go home, read through some documentation in a quiet weekend, come back to the office Monday morning and be fairly ramped up on the DX version for the mobile space. So people can come over and leverage this knowledge very quickly. Also, it's a commonality of knowledge. If you have a large development house or you're creating content for a number of targets, if you're creating perhaps a desktop application or a Windows mobile application, there's no need to understand 3 or 4 different API sets or 3 or 4 different proprietary engines. If we can try to create one DX knowledge base that you could leverage, the team becomes more efficient, the knowledge becomes more efficient, which again leads to faster development time, more efficient creation of your content. The knowledge base is another key aspect of this. Again, DX is nothing new. It's been around for many years. So is the community. So have lots of questions that have been asked of, how does this API work? Or what is this structure meant for? Now, certainly there's a large gaming ecosystem for Windows Mobile, but it is just for Windows Mobile. I can go ask a GAPI question or some other proprietary engine, and I'm sure I'm going to get an answer from the community. But if we can combine that with the larger DirectX community, create a lot more developers and get that knowledge out there and even expand the system even more. And people have experience. If you ask them a question, which is the most efficient path for something? Obviously, there's architectural differences. There could be differences in how structures are defined. But to understand the flow of a program, perhaps where you're getting blocked or you're getting bottlenecked somewhere, that can be leveraged from the desktop, and you can leverage that knowledge. And we want to make sure we continue to do so. There have been investments in this, and we want to make sure we can continue to capitalize even in this space. So, as I've said, spoken of DX technologies on a high level. Why is this great for developers? Well, what are we really looking at in particular? There are two key technologies we're looking at that are being actively developed for a future version of Windows Mobile. First of which is Direct 3D Mobile. So I've touched on earlier, and as the name implies, this is a complete 3D API based on the desktop version of Direct 3D. 3D content is becoming more prevalent on devices. Developing them is becoming more complicated. We're starting to see hardware that can access this. We want to provide a mechanism, a standardized mechanism, for both driver writers and yourself being content developers to write this content, to write it across all Windows Mobile platforms. The other key technology we're bringing to the mobile space is Direct Draw. This is equivalent to the technology on the desktop. It's based on it's a 2D API designed for content development. One of its most important characteristics we'll see is standardized hardware access. Now, both of these were examined, their architectures, what they offer, and they were designed for the embedded space. Obviously, my pocket PC or my smartphone isn't my 3 gigahertz PC with a ridiculous graphics card. It's also not a streamlined, dedicated console like the Xbox. There are certain things that are advantageous to keep, and certain things we decided to re-architect or adjust. So Direct 3D Mobile. 3D API, it's a COM-based model based on the DX8 API, D3D8 fixed function pipeline. It's a subset of the technology. We didn't thunk over the entire API set. We evaluated what APIs and what technologies we thought were suitable for mobile content development and incorporated them over. Now, the reason we started with the D3D8 fixed function pipeline is that when we began this initiative, D3D8 was the currently released DX technology. So Microsoft has been investing in this for quite a while. Also, DX9 was released sometime thereafter. In fact, continued during our development. Now, the DX team on the desktop made a number of enhancements to their technology that we saw value in bringing over to Direct 3D Mobile. We'll go into a little detail on what some of those specifics are shortly. But at every opportunity, we evaluated what value could we bring to the developer? What extra features does it make sense to bring so you can leverage in your content development? Now, memory footprint and size is always something critical in the mobile space. We don't have as much RAM as we want. We don't have half a gig of RAM on memory cards. We have to be conscious of what we're including in our design. And the design of Direct 3D Mobile was streamlined to have the smallest possible footprint, the smallest possible memory utilization. Finally, Direct 3D Mobile is architectured to leverage any mobile device platform. Now, we think of 3D today on the desktop or the Xbox, think of some ridiculous hardware graphics acceleration. Now, in the mobile space, we have wildly different architectures. Direct 3D Mobile is designed to leverage any of those platforms. You could just have an ARM processor. You could have a full pipeline. You could have a DSP. And we'll see how that's incorporated into the driver model and made seamlessly exposed to the developer. So in creating Direct 3D Mobile, to provide you some insight into how we approach the problem, we set up a number of goals to really create the API. At a high level, we want to provide the best 3D development experience across all Windows Mobile devices. That seems like a simple enough statement. Mobile device community, especially in the gaming and graphics technology, is wildly fragmented now. If I look at my various versions of Java, my various proprietary engines, they can vary from device to device. And largely, people have to target one device or another engine. One of the goals of Direct 3D Mobile was to create a 3D API that was standardized across Windows Mobile. Windows Mobile is designed to be a platform. We want to make sure you can leverage it as a platform consistently. Continuing on the idea of an ecosystem, the DirectX ecosystem from the desktop is a powerful thing. Much like the .NET CF ecosystem expansion from the desktop, we want to continue the DX ecosystem the ways I mentioned earlier. Also, the API itself, we want to ensure that the API that we create can best leverage the characteristics of the platform. You're doing 3D development, you're going to write 3D content, but you want to be able to access certain hardware characteristics seamlessly in your content. Finally, the idea of the best-in-class solution for Microsoft technology over third-party offerings. For those of you who are familiar with content development, there are a number of engines you can choose. There are a number of APIs and a number of standards, OpenGLES being one of the more prominent ones in recent months to emerge. Now, in developing the Direct 3D Mobile API for Windows Mobile, we're driving to ensure that we have the best solution available on our platforms to expose the most powerful hardware we have. Now, this has been a particularly interesting scenario in content development, that many people come and say, well, I have my J2ME engine, I can write to anything, or I have a standardized engine I can write across a number of platforms. Looking at Windows Mobile and the power of the hardware, we don't think that creating the same content everyone else has is really a way to distinguish. Now, if we look at the hardware design, we have very powerful processors. The platforms have higher resolutions now, more memory, graphics acceleration than most competing phones and PDAs. Now, if you write a piece of content that looks the same as some little freebie phone you get from T-Mobile, how are you really showing off the platform, or how are you distinguishing your content? By providing a best-in-class solution, we want to ensure that you can write content that people don't just say, oh, I have my little 3D racing game. It's, oh, that's interesting, but wow, how do I get my hands on that? We think that's going to be the key to really distinguishing the platform and distinguishing your content as you develop it. Final goal that's extremely important to us is to be able to access graphics features not only now, but tomorrow. Hardware is developing very fast in this space, especially graphics hardware we're seeing is emerging at a far more rapid rate than the desktop. 2D acceleration is now fairly common. 2D plus forms of 3D are emerging. It's only a matter of time, most people believe, until full 3D pipelines are available in mobile devices. Now, with the driver model we've created for Direct 3D Mobile, believe that the developer can write your code to a driver. You can say, I want my triangle on the screen. And I should be able to replace that driver or replace that architecture, and your code will still work. That triangle may get there faster, may get there more efficiently, but it'll still function from the development layer as the same as it did before. I mentioned that Direct 3D Mobile is a bit different than Direct 3D. There's some additions, there's some things removed. So what are the key features we're looking at for Direct 3D Mobile? One of the more prominent of these is type-independent support. The desktop only includes support for IEEE 32-bit floating point values. Now, on my Pentium desktop at home, that's great. I have hardware FPUs. I have GPUs that can process this natively. As many of you are aware, we don't have that luxury in the mobile space. And having to go through floating point emulation either costs you performance in your application, it's going to cost you power to actually perform the calculations, and very will likely degenerate your end-user experience. To help solve this, Direct 3D Mobile's included 1616 fixed point data type. So you can write in this fixed point format, have it drop directly to the hardware to achieve optimum performance on the platform. Now, evaluating the 1616 fixed point type, we believe this is a numeric type that most developers are familiar with who have dealt with fixed point formats, and something that's not too difficult to get involved in. We did evaluate a number of other number formats, variable type formats, variable precision formats, but in the end, we believe this is the best route for developers in the development community. In fact, the idea of fixed point values versus floating point, internally we had run a number of tests on large-scale content clips, applications, using both fixed point and floating point emulation on various fixed point platforms, ARM-based platforms. Some of the test runs we had changed from, I think it was about 45 minutes to an order of about 25 days to run, which obviously isn't the same for all applications, but it gives you an idea of how much power and performance we're losing. And ultimately in gaming, on the desktop, performance is king. In this space, performance is king, but how much power are you consuming as well? And if we can give you every advantage to leverage your performance and your content, we want to make that available. I mentioned earlier that there's some constructs from DX9 that we had leveraged into our API that weren't available in DX8. Two of these are 2D APIs that were introduced, stretch, rect, and color fill. Color fill just fills a given 2D surface, so the color, as the name implies. Stretch, rect, similarly, performs a change from rectangle A to rectangle B, perhaps some texture filtering if you'd like that applied. But these are 2D APIs that we can incorporate in our model, give added value, we believe, to the development community should you want to leverage it. So we decided to include it. Another difference was the way we dealt with z-biasing and sloping. Instead of a z-biasing method, we incorporated the new depth, slope, and scale bias methodology from DX9, give more accuracy, help limit z-fighting in our technology. It's an improvement from the desktop that they admitted over the DX8 implementation, so we decided to incorporate that. Another critical difference from the desktop is Direct 3D Mobile is not explicitly tied to the DirectDraw technology. For those of you unfamiliar with the D3D desktop implementation, Direct Draw is effectively incorporated into the desktop D3D API. The calls exist, they all bundle together. In the mobile space, you realize that componentizing technology is important and keeping them independent is important. So you're not required to load DDraw specifically to run Direct3D mobile applications, unless a driver is written to explicitly leverage DDraw. Now, one important similarity I think I should point out is that Direct3D Mobile supports both a windowed and a full screen mode. Now, admittedly, for a smartphone and gaming applications, it's most likely going to be written in full screen. But as we look ahead at higher resolution devices, resolutions that start to infringe upon what the desktop has, we want to ensure that this option is available. If you want to write windowed 3D content, you should be able to. As more screen real estate becomes available in larger size screens, we don't want to limit you to just full screen applications, for example. So this is at your disposal. Now, the architecture of Direct3D Mobile is probably one of the more striking differences from the desktop implementation. There are two main components. One, there's an API middleware. This is d3dm.dll. This links to the headers. It's what you link into your application. Right now, it weighs in at about $70K for an ARM retail build. So it's actually a pretty small component for 3D. Now, the middleware is responsible for synchronizing with the operating system, handling error routines, generating command tokens from your API calls that get dropped down to the driver. That's all the middleware does. It's very small, it's very lightweight. Admittedly, also, it doesn't do that much. One of the main reasons being we've removed all software emulation fallbacks from the middleware and pushed this functionality down to the driver. On the desktop, if you have a path that's not supported in hardware, the middleware is supposed to emulate this in software and actually produce the correct results. On the desktop middleware implementation, this results in a large amount of redundant code, or potentially redundant code. Have something that you could leverage in hardware, it's now mirrored in software. Looking at some of the space restrictions and the size constraints that we were evaluating for the API, we didn't want to necessarily include a large amount of redundant code. With memory footprint and memory loading sizes being critical, we wanted to shed as much as possible. So all this functionality is pushed down to the driver layer. And the driver layer is actually where the drawing routines occur. And there's both a benefit and a disadvantage to this. The disadvantage, one could argue, is, well, the driver now has to pick up a lot of work. And depending on what type of architecture you're writing to, that could actually be the case. Now, if you're running a pure software solution that gets loaded in process space to handle all the 3D calculations of the pipeline, eventually running out to a surface, the entire 3D pipeline has to be written in software. And that can be quite a bit of code. Conversely, if you have hardware, such as DSPs or a full graphics pipeline, you can just make the calls directly out of the middleware and write into this hardware. Now, from both Microsoft's point of view and as an application writer, once you create a call to an API, a command token is generated, it's dropped to the driver. We're not concerned with how the pixel gets on the screen so long as the pixel is correct. And likewise, if you ask for a triangle to be drawn, as long as the right triangle is drawn correctly onto the screen, it shouldn't be a concern of yours either. Now, this provides the freedom to platform designers or driver writers to leverage any hardware they have under the hood. If you just have a proc and you're loading in process space, okay, leverage the characteristics of your proc. You have 5 DSPs, you have some unique media processing engine you can leverage, by all means, take advantage of it. If you have a full TNL pipeline that you're going to leverage in a GUIs-loaded display driver, it's your option as well. So this freedom allows you to just write your API and leverage any characteristic of the platform. I know this has been a lot of high-level talk of the code, but really, given all of the VS Live talks and the other talks we're seeing, what about managed versus native? Now, managed code is obviously important to help cut your development time, get you up to speed rather fast. But gaming is also a domain where performance is incredibly important. A lot of people, a lot of developers, I'm sure some of you included, will look for the fastest path. We'll look to tweak the architecture to really expose your content as the best content on the device. And we want to make both options available. Now, for the managed route, we're really looking to wrap what we call the D3DMX helper libraries. Now, these helper libraries are a subset of what's offered on the desktop, and these are a series of API calls designed to help ease your work. Mainly right now, we're targeting things like transforms, matrix multiplies of all kinds, texture loading routines. These are things that you'd have to write for any application, write again and again, or write your own libraries. So we're providing them, and we're providing managed wrapper support for them. So if you choose to leverage that route, you're free to do so. If you want to go right to the metal as well, it's your option to do. And a lot of these routines, especially the D3DMX helper libraries, a critical thing we're doing is providing support for both the fixed point and the floating point versions. Now, we can go to the internet right now and look up, well, how do I do something in D3D in floating point? And we're pretty much going to find an answer rather quickly. If I say, how do I leverage something in D3D in fixed point, it's not quite available yet. So we want to ensure that we provide routines and code that exercise and show these fixed point math routines, so you can leverage them and get a better understanding of them. As I mentioned earlier, the drivers are a leading component of the Direct3D Mobile architecture. A lot of the work is done in the drivers. Unfortunately, my team can go off and write optimized drivers for every platform under the sun. Not only do I not have enough resources to do our regular work, but we don't claim to be the experts of every single architecture nuance out there or the new architecture that's coming out. In order to ensure that drivers are available, we've been working closely with both OEM hardware designers as well as graphics hardware partners to ensure that drivers are available for future releases of Windows Mobile. So when the devices are ready, as people are ready to start developing against them, these drivers will be ready to be leveraged and in devices. Having this driver support is critically important to creating that ecosystem, of creating the entire platform play, to ensure that you can find Direct3D Mobile across all the devices in the Windows Mobile domain. Now we can see here a number of partners, Intel, TI, Samsung, particularly driving its software-based solutions or leveraging some of their DSP hardware. Graphics partners, PowerVR's Imagination Technologies, ATI, NVIDIA. There are a number of other proprietary engine developers, graphics firms that we're speaking with. We're working with all these groups very closely. More continue to join every day as we move further into this initiative. And there are two things that I was told when I was asked to give this talk. One is that if I don't show some bit of pixels, people are going to yell at me, or if I don't show some bit of code, people are going to be a little upset. So thankfully today we have both of those that we can try to leverage. This pixel is already a good thing, and let's load this up, get this on the screen. Now obviously there's going to be a bit of color distortion from the actual Pocket PC device. What I'm running right now is a Toshiba E750 with a PXA 255 X-Scale core. This is just a demo, which please come by afterwards and see more clearly up close. Unfortunately, the projector doesn't do it justice. I think it's getting a little confused on the depth that we're giving it and the colors. But this right now is driver technology written by Intel, optimized for the X-Scale platform. This entire pipeline is producing everything in software optimized for the platform to give you a notion of what some of the performance characteristics we're looking at. And here's just some point of results from this. This is pumping out a little under 30 frames a second for its design. Now, obviously, when most people think of software, they think, oh, well, how fast could it be or how efficient can it get? And obviously, there is an order of magnitude difference between a software pipeline and full hardware. But that being said, we're starting to see some rather impressive results out of software pipelines that will exist on many platforms as we move ahead. Let's see. So that was a bit of the demo part. I keep my promise on the other one. Some code. Unfortunately, in a talk like this, since we're asked to evaluate a large set of the technologies, this isn't meant to be a drill down on D3D programming. I could have spent the entire conference going through that. But the point of which I wanted to include this information in this slide so you can review it later is really to express some of the differences between Direct3D Mobile and Direct3D, or really the lack thereof. Now, this is a code fragment out of one of our samples that just puts a triangle up on the screen. It's obviously more code to load the driver ahead. There's some cleanup code afterwards. Cleaned out most of the little error-catching macros to concentrate on what we're looking at. All this really does, it calls a clear routine to clear the primary surface, set up a scene marker, say I want to begin my scene. DrawIndex primitive is just going to put a single triangle onto the screen, end my scene, and present. All this does is say, give me a scene, let's fill it with a triangle, let's dump it out to the display. The reason I want to show this is the difference between this and a D3D implementation is actually one letter. Now in this, we see iDirect 3DM device, D3DM clear, D3DM color. That M is the only difference between this implementation and the desktop implementation. So if one was to go home and try to compile this up in a part of a larger program for the desktop, you're effectively doing a find and replace, which is a large part of what we're looking at. That was part of the design, to be able to leverage code over. So if you're bringing code from the desktop, in many cases, as I've seen people do, it's find and replace to add that M instead of remove it. We tried to maintain as solid a development base from the desktop as possible. In fact, things like our basic render states are all the same as the desktop. Our caps bits are almost all the same as the desktop. The default states that these start in are the same as the desktop. for that particular reason, of leveraging the desktop, of leveraging the code and the knowledge base. So I've had my little description of D3DM, something I work with very closely, so I spend a lot of time on it. I guess my reason for driving so deeply. The other technology, DirectDraw, the 2D graphics API brought over from actually the version on Windows CE. Now, the version of DirectDraw on Windows CE was ported from the desktop version 6.2 of DX. It was brought over for a separate project. One of the main focuses of DirectDraw is that it allows you standardized access, not only in the driver model, but at the API level to 2D hardware acceleration. Now, seeing the increased amount of 2D hardware acceleration available on Pocket PCs and emerging on smartphones, I believe this is incredibly important technology to have. Now, there are a number of targeted scenarios, one of which is 2D content development if you're doing 2D-based games. The other important thing is if you're doing video playback applications and leveraging any form of video. Perhaps you're doing some form of content that has, instead of animation, you want to include video clips as segues or video clips as information. If you're going to do that, leveraging DirectDraw not only gets it to the screen faster, but it leverages the hardware that you have. Now, as I mentioned, we have DirectDraw on CE. Well, why don't we necessarily have it on Windows Mobile up to this point? Well, one of the reasons is still the footprint. When DirectDraw was ported over from the desktop, the target platform was a bit more ample than a standard Windows Mobile device. So the amount of pruning in the code wasn't done that carefully. Now, given some of the footprint requirements to squeeze all the features into Windows Mobile, and I'm impressed on a daily basis we can continue to include more features, we need to do a little more trimming. Currently in CE, we're looking at about a 400K footprint. We're trying to target a sub-200K footprint reduction for Windows Mobile. And one of the reasons this is occurring is by eliminating both redundancies in the software fallback stack and the API layer. Those of you unfamiliar with DirectDraw's architecture currently, much like Direct3D, if a path isn't available in hardware to leverage some routine, software emulation occurs, and it's displayed out to the system. Now, in DirectDraw right now, there's an independent software stack that performs this emulation. 90+% of these calls also exist in this other graphics component called GDI. So right now we have two graphics subsystems or stacks performing software emulation that do almost the same thing. So if we look at these stacks, if we remove this one in DDraw, just rewire everything to GDI, we've now cut out quite a bit of code, made things a lot more efficient, and decreased the memory requirements, the memory load. Another aspect of the cleanup is an API consolidation. For those of you familiar with COM-based development, I'm sure many of you have seen ICOM interface 1, ICOM interface 3, 4, 12, whatever you're up to. DX from the old days is no different from that, unfortunately. So when we went back to evaluate the API and said, if we're going to go back and do this cleanup work, we want to consolidate the API set for the COM interfaces. So there is just iDirectDraw, no iDirectDraw 5, 6, 7, with any number of other interfaces. I think it makes cleaner code, makes it easier to read, makes it easier to write to. It also consolidates all the methods and everything, so it's a single API. Another important characteristic is rotation display support. As we're developing DirectDraw, we're aware that there have been a number of advances in the display technology, the rotation support in Windows Mobile. I want to make sure that DirectDraw is aware of this rotation or your orientation and behaves correctly when you're in that rotated mode. Now, looked over some graphics technologies. I want to take a little look at how this is going to change in the future, or how we perceive this is going to change in the future. On the left side of the screen, the lighter blue, GAPI, and GDI, this is what Windows Mobile looks like today. If you're writing mobile content, have GAPI, which give me my frame buffer pointer and let me go party right down to the hardware, and GDI for your software development. Now, DirectX provides a number of more complex APIs, much more powerful APIs. But again, that complexity comes along. DirectDraw has two main components, known as the HEL and the HAL, carried over from DX. The HEL is the hardware emulation layer, which is this software emulation layer for graphics calls. There's a call that isn't available in hardware. We're looking at the HEL to make a call over to GDI and get it out to the display system in that path. The HAL is the hardware abstraction layer. If you have hardware color space conversion, overlays, flipping, whatever you happen to support in your hardware, we want to make that call directly down to the DDI saying leverage this hardware path. Now, the DDraw architecture model here follows identical to what the Windows CE has and in line with what the desktop has. Now, Direct3D Mobile is a bit different in its architecture. As I mentioned earlier, there's a number of options. You could have a software driver, some DSP mix driver, a full graphics pipeline. So the line in which the D3DM driver exists gets somewhat blurred. My software driver could be loaded in proc. My hardware driver could be loaded in GUIs. So that's the reason why this line gets a little blurred at the DDI layer. And ultimately, everything goes down to the graphics hardware, which thankfully is improving over time, and goes out to the system. Well, John, you spent a lot of time talking about graphics technologies, heard a lot about D3DM and DDRAW, things we're excited to see. For those of you who are familiar with DX, there are other components of DirectX that are out there. Two in particular we're looking at are the input and the networking model. And on the desktop, there's a technology called direct input. This is designed to abstract input methods. Now, on the desktop, this has been used for keyboards, mice, joysticks, little steering wheels and foot pedals, pretty much anything you can imagine. You may think, well, what similarities do we have in that to the mobile space? And looking at a lot of the devices we have, we think there's a critical need for this. Look at all the buttons that exist on phones now and all the functionality. It could be D-pads or joysticks. The direct input model on the desktop even has the notion of force feedback. So imagine writing content to your device where your vibrate mode is force feedback on content you've created. The goal of direct input would be to try to abstract that model so you can write to an abstracted layer and not be worried with the underlying hardware details. This is something we're evaluating for down the road in Windows Mobile. Another aspect of this is the networking model or dplay. On the desktop, this is used to abstract effectively socket calls. As a developer, you just want to say, open up my socket, talk to a node on the other end. This is how I want to communicate. On the desktop, originally, this was designed to help mitigate your serial RS-232 links, your null modem, your regular modem, your LAN network, anything you can imagine. And developers don't want to be bogged down with that. Looking at the mobile space, when we realize the network connectivity, there are new challenges. If you want to write a piece of content to talk to another device, you don't have to worry about, am I going over GPRS, or am I doing an ad hoc Bluetooth network? Or perhaps I'm sunk using ActiveSync and going over the internet. That shouldn't be a concern to you. So we're looking to try to abstract that as well through this standardized model. And again, these are being considered and evaluated for future releases of Windows Mobile that we believe will provide not only a value add to developers, but help further create the DX ecosystem in the mobile space. So when are we going to start seeing these come around? Again, these are future Windows Mobile technologies. It's great to talk about the future, can look down the road, but obviously you get people excited, they want to start playing around. So to give you an idea of how this is starting to unfold, currently driver development betas are being distributed to our hardware partners and our driver development partners for Direct3D Mobile. Some are more advanced than others. Some are working with sets of hardware that are emerging only now, but they're actively developing their drivers and evaluating their technologies and looking ahead for Direct3D Mobile and how it aligns with the greater ecosystem. Now, Direct3D Mobile, again, when you come to a lot of these future talks, you may think, well, what kind of smoke and mirrors am I looking at? Direct3D Mobile v1 is going to be available in Windows CE Macallan later this year. It will be RTM'd. It will be an available technology. This isn't something that's 5 years down the road. It will be here before you know it. And if you want to, you can continue to read up on it in that context. Looking ahead at future versions of Windows Mobile, D3DM and DDRAW are going to be available for you. As betas come out, as they emerge, by all means, from the development community, grab them, play with them, read up on them. And down the road, as we see hardware emerge, we want to ensure that that's online too. As I mentioned earlier today, 2D and 3D acceleration on devices is becoming more prevalent. This is going to continue at a very rapid pace. We want to ensure that you can write the best content to leverage these platforms, and that we're providing the best API to expose them to you in the most uniform manner. So some of this still consists of down the road. What do we do today as a developer? Well, there are a number of things you can start evaluating and keeping in mind as we look ahead at these future DX-based technologies, some of which is about content. What kind of content does your firm have or do your partners have that you can leverage? Do you have 2D-based content, DDRAW content, old 3D content, or Xbox IP that you could use? Considering what can be better aligned or what you can leverage down the road is important to do now. Obviously, the future is always tomorrow, but invariably, when we're not thinking about it, it comes here sooner than we think. And the mobile space and gaming development is obviously much more rapid than the desktop. It doesn't take 3 or 4 years to release a title, but it does take some time and some ramp up, especially when we're looking at more complex and more rich environments and APIs. Looking at other aspects, perhaps there are enhancements you can make to your content. Perhaps add 3D UIs or other 3D elements to your games to make them more attractive, to make them stand out from the competitor. Now, as future versions of Windows Mobile come out, and as beta releases come out, by all means, I encourage you, grab the docs, grab the samples, start looking at the code, get ramped up soon. Now, Microsoft has spent a lot of time investing in DirectX. For those of you who have been looking through some of the recent press releases regarding the future direction of DirectX and the larger Microsoft initiatives, it's not going away. It is coming to the mobile space. It's a corporate-wide push that will be extended, and we want to ensure that you're aware of it and can best leverage that. Now, there are a number of places to look for more information. By all means, the news groups, people you know, people you meet at Microsoft. There's an alias set up, d3dminfo@microsoft.com. If you have questions about Direct3D Mobile, DDraw, future DX technologies, please send to this alias. It's what it's there for. Actually, I'm very eager to go back to the office and see if anyone's sending me mail. Hopefully none of it too bad at me, but we'll see what happens. And I encourage you to send feedback, things you want to see, things that you think are missing, new directions you think we should be taking, or if you're happy with the way we see the future. Now, there are a number of resources available. I'm sure that this has been seen once or twice. Looking at a futures talk, obviously, these are technologies that are emerging, that aren't here today. So rushing right out and saying, when can I get my API, is going to be perhaps not the most fruitful endeavor. But I encourage you, again, to follow up with developers at Microsoft that you're in contact with. Follow up with the development community, the news groups. Ask for information. I'm just as curious to hear about your thoughts as I'm sure you are to ask questions. Another thing to mention for gaming and development, looking ahead at the future, these are a number of talks I'd recommend seeing. There was a gaming talk earlier this morning, which hopefully you can find information on if you didn't attend. Gaming development with the .NET Compact Framework, a look at more managed side of content development is coming up in the near term. Also some other talks looking at both future Windows Mobile APIs as well as the Windows Mobile hardware trends. As I mentioned earlier, with hardware becoming more sophisticated and especially graphics hardware increasing at the rate it is, it's important to take a look at where we think this is going and how this is emerging and how you can prepare to really leverage that next generation content you want to create for your device. So with that, as I mentioned before, it's the conclusion of my talk. I thank you very much for your attention. And by all means, I welcome questions or comments. I think you had your hand up first, so you can... Question was, why is direct sound not listed? Direct sound is a technology that is being evaluated. Right now, it's being evaluated initially for its inclusion in Windows CE Macallan. So it's something that we're looking at, but compared to the other technologies we see, we think that these are more important. With the Sound API, we see a distinction in that there is a Wave API available that people can leverage. And obviously, if there was a DSound, you could leverage that code base. Things like input, things like access to graphics, hardware acceleration, really don't exist in a standardized model today. So that's where we're placing our priorities. But it is something that we are discussing and considering. Yes? Question was, are we looking at a managed version of Direct Play? For all of our DX technologies, we are evaluating managed solutions. Now, when they occur and what form they occur in, that's, again, with, unfortunately, the notion of a futures talk, we'd have to shake the crystal ball somewhat. But as with all of our development efforts, the question of how does this fit into the .NET Compact Framework emerge, and that's something we certainly take into account. Sorry, just 1 second. The question was, how would I compare and contrast Direct3D Mobile to OpenGLES? There's actually a long list of discussion on that. At a high level, in evaluating OpenGLES, we believe that the Direct3D Mobile API is more powerful and does expose more functionality than OpenGLES. And evaluating its architecture, we believe it's best suited to provide the best experience for 3D development on a Windows Mobile platform. We can go into more depth if you like offline, but... sorry, there was a question on DShow. Question is, what about DShow? That is a DirectX technology from the desktop. DShow is seen more, oddly enough, as an independent technology of this, in that DShow is very much multimedia application. There's a certain multimedia technology that's leveraged in Windows Mobile that at the moment is not DShow based. So DShow is actually one of the DX technologies that we are evaluating, but independent of the mobile gaming approach. It is being evaluated as, does this fit into the platform? So it is something we're considering. Yes? I So the question was, for those unfamiliar with DX technologies or Direct 3D technologies who'd like to know more, where do you start to look as Direct 3D Mobile is emerging? Certainly, I would recommend that starting with the D3D8 tutorials and online documentation available from the DX site and the DX SDK is probably the best place to look. There's freely available, I think, either off of MSDN or Microsoft.com/DirectX. And there's a number of tutorials to get you ramped up in how do I get my device up and running? How do I get texturing load going? How do I get triangles on the screen? And that's probably the best place to start to move forward from there. Question was, can DirectX 9 offer DirectX 8 interfaces? In many cases, the interfaces are, I don't want to say identical, but they're very similar for when they replace them. DX9 does offer a large set of new technologies that aren't available in DX8. The one reason I'd be somewhat wary in jumping directly into DX9 is that DX9 incorporates far more functionality towards the vertex and pixel shader architecture and starts to remove from the fixed function pipeline implementation. So you start to cross the line of leveraging specifically the high-level shader language or the shader languages versus how do I just use my standard graphics pipeline. So that's the only thing I'd keep in mind when evaluating that. Yes, question in the back? The question was, does the Visual Studio 2005 beta, was it you're asking about, include emulators for Direct 3D Mobile? I do not believe it does. Yes. The question was, how should one approach content development that leverages both future technologies such as Direct 3D Mobile and current devices such as Windows Mobile 2003? And that largely depends on the type of content you're creating and what your objective is. Now, with Direct 3D Mobile, we see, quite honestly, very advanced content being developed that, unless you're using a very high-level graphics engine or gaming development engine, will be very difficult to create. If you're doing massive 3D game, reproducing everything at the low level in GAPI, for example, will be quite painful. And we do see quite the fracture of one using GAPI and a frame buffer to create their content versus here's a complete 3D API. So it's very difficult to say how do you best leverage the practices from one to the other. So I wish I had a silver bullet for that one, but that really is evaluated point by point. So to clarify, it's one wants to release on both. How do they best architect? Yes, it did. And if you write to D3DM, it will work on D3DM. If you don't write to it, unfortunately, it will not. So at that point, sorry. Certainly, I mean, if setting up a scene, setting up your artwork, setting up your loaders is, in many cases, when you've actually gone to that point, it's how do I translate that to one API to the other? Again, you may want to leverage functionality that doesn't exist on these engines that Direct 3D Mobile offers, but it's a route to consider. There's a question down here. The question was, do we have any plans to incorporate Direct 3D into the emulator? That is something we are considering. There are a number of options we're evaluating to determine the best way to get people up and running on a platform, whether it be through the emulator or through some other more standardized driver that can be loaded on more conventional hardware. Yes. So, yes. So just to touch on that again, I think the question was, what about other non-3D specific or supporting roles for devices? There's really two aspects of this. One, you are correct in that a lot of the near emerging technologies we're seeing are are very graphics focused, either 2D or 3D. So that we believe that does cover the breadth of things. How someone develops it is really the imagination of the content developer. So if you have MechWarrior on Xbox, for example, and you just want to have your 3D maps created on your Pocket PC so you don't have to have everything on the screen, that's something you could easily leverage, and that tool will be available. But again, the content developer is the one who has to write that. The other tools as well, the input model, the networking model, these are things we're evaluating to get online to create that larger solution to say, here is Microsoft's comprehensive solution for everything at an abstracted high level. So it is something we are taking into account. We aren't just examining this as, yeah, 3D is nice and trendy, so that's all we're focusing on. It happens to be one of the larger initiatives and more recent initiatives. But there certainly are other pieces to the puzzle. Yes? So the question was, will GAPI be deprecated at some point? Personally, I don't know if GAPI will be deprecated at some point. It's at the whims of people above me, unfortunately. That being said, direct draw should provide access to a 2D surface if one wanted to write to directly. So the functionality, equivalent functionality, at least at the graphics level, will persist in the DX form. I can't speak of whether or not GAPI will be deprecated or not, though. Yes?
What's a good resource to track trends in the Windows mobile gaming community? I find sometimes it's difficult because a lot of the kind of rockstar developers in 3D games are very distributed. You stumble across some really elegant 3D engines, but it's hard to view these all in one sort of consistent community like IBM and things like that. Do you found communities that are really focused on 3D Windows game development?
The question was, have I come across any communities, I think online or otherwise, I take it, that are focused on gaming development, content development, particularly 3D in the mobile space? One of my favorite haunts is pocketmatrix.com and the community there. I don't know if you've gone to that or not. That's a site really dedicated to mobile gaming development, and that's one of the better resources I've found. Other ways that I just keep in touch with what's going on are, of course, admittedly the other favorite haunts. Think of the Register, think of Slashdot, things like that, where little news does creep in. But from a strictly mobile gaming community perspective, I'd say start with pocketmatrix.com, and you'll be branched off to other places from there, I'm sure. Yes? Question was, what are Microsoft's plans for creating mobile games in the market? Sure. Any other questions? If not, I thank you for your time. I'll be floating around the conference for quite a while, so if you have anything else, please track me down.